Hello, I'm Cathy Cook. I'm the project coordinator for the school's energy project. This video is to help householders undertake thermal imaging surveys of their own homes.
If you haven't yet viewed part 1 of this video, I suggest you do that now, as part 1 helps you get started with how to use a thermal imaging camera and highlights the pitfalls to watch out for. So what we're going to be focusing on in this second part of the video is what to look for when you're thermal imaging your home. Firstly, we're going to help you to identify where heat is leaking out of your home, and this may be through holes and gaps or where insulation is inadequate. Then we're going to look at identifying insulation and heating defects and moisture ingress, and then most importantly, looking at improvements and checking if they're working. First of all then, let's look at some thermal images which show heat escaping due to holes and gaps. We're going to show you some examples of heat leaking out of windows due to gaps that weren't easy to spot with the human eye. For example, this is a thermal image of a wooden window that was actually closed, but the white vertical area shows where heat is leaking out. This gap wasn't visible to the human eye. Draft excluder tape would be good at fixing this. If you have a similar problem, have a look online because there are a number of different draft excluder tape products, and retailers often provide helpful videos showing you how to install it. Also, take a look at the Energy Saving Trust website because they have loads of advice on how to tackle all sorts of heat loss problems around the home. Here's another example, a reasonably new set of French windows. They were definitely closed, but the thermal image shows the white of the warm air leaking out of the top of the windows. The best option here would be to get the installer back to adjust them. In this picture, this old metal framed window was closed, but the white lines on the thermal image clearly indicate that warm air was escaping. Again, some draft excluder tape would help to fix this problem. And in this picture, these high-level windows were clearly open and allowing a lot of warm air out. But it turned out that the winding mechanism was broken and the windows couldn't be closed. Once this issue was highlighted by the thermal imaging survey, it only cost £85 to get it repaired, and the difference to the comfort of the whole building was instant and dramatic, as no doubt was the effect on their heating bills. Now, here are some examples of holes allowing heat to leak out from people's properties. This keyhole had no cover and was permanently allowing warm air to escape. Now, although it's only a small hole, it will never actually stop letting the heat out. So overnight, the space next to the keyhole would probably drop close to the outside temperature. All this needs is a new cover fitted. That's a really cheap solution. This example is of an early 1900s house with quite a few holes in the mortar on its front wall. The thermal image on the right shows the red spots indicating how warmth was leaking out of these holes. The householder had commented that on the inside the room was often cold and draughty, so there was evidently a clear route for the warm air inside to escape out through these holes. A bit of mortar would instantly fix this. For extractor fans, if there are no shutters or if they're broken, this will mean there's a continuous route for the warm air to exit from the kitchen or the bathroom even when the fan is switched off. The solution here would be to either get a new fan that does have shutters or to fit new shutters to the existing fan. And don't forget, after you've checked the outside of your home with the thermal imaging camera, it's really important to use it to check your windows and doors on the inside too. And remember, when you're on the inside, you'll be looking for black and purple areas in your image which indicate the coldest part of what the camera is seeing. That's where the cold is getting in. For example, this is an image of a new front door with a lot of cold air getting in underneath it. What it really needed was a brush strip along the bottom to help reduce this problem. Unfortunately, front doors do get a lot of use, so the rubber sealing strips and the brushes wear, and the hinges can also start to sag, so they often develop gaps and get drafty. And if nothing's done, this can cause a whole house to feel unnecessarily cold. Here's another example of a problem front door which wasn't really visible with the thermal imaging camera from the outside. On the inside, though, it was clearly showing signs of letting in cold air. This image shows the temperature at the bottom of the door was 7.1 degrees centigrade. That's very uncomfortable. And this image shows that there was also a problem at the top of the door, with cold air coming in at 8.7 degrees centigrade, which was simply adding to the chilling draft at the bottom of the door. Ooh. This was tackled by fitting a heavy curtain across the door, which significantly reduced the problem. A 6 degrees centigrade rise in temperature was achieved and made the hallway feel much warmer and also damped down the drafts elsewhere in the house. Here's another case of a cold front door.
This householder has told us they've got a drafty front door. So let's take a look. Yes, we can see the thinner wooden panels are quite warm. The red is showing where the heat is leaking out. You see the range of the photo, the range of the thermal image is shown here on the right hand side, and we have the spot there in the middle giving the temperature up in the left hand corner. So the spot temperature is 9.2 for the thin wooden panel. For the thicker part of the door it's 6.6, yeah, it's steady 6.6. So that's actually telling us the main issue is the wooden panels on the door, which is letting the heat out. Now we can see the inside of this same front door, and we can see that the temperatures that the camera is seeing are the opposite to how they looked on the outside. So on the inside we're actually looking for the darkest colours, the black and the mauve. Those tell us where the coldest temperatures are. So we can see here's the inside of the letterbox. You see that in the spot, the crosshairs in the middle, and that is registering at 9.4, 9.5, 9.6. Yeah, so that is quite cool. I would say that's probably where the most cold air is coming in and the most warm air is getting out. Thinner panels on the inside of the door are showing as mauve, and that's cold too. So that's 12.2 degrees C, 12.1 degrees C. And on the outside, the temperature, if you remember, was 9.3 degrees C. So we've got a temperature difference here of about 3 degrees C between the outside and the inside of these thin panels. In comparison, the thicker part of the front door in the middle is registering a temperature of 16.8 degrees C. So with the outside temperature we saw of 6.6 on that part of the door, this shows we've got a temperature difference of about 10 degrees C. So we can see that the thicker wood is a better insulator than the thinner sections on this door. The main issues with the door are the thin wooden panels and the letterbox. Here we've just put in place a sausage roll type draft excluder, and that's a really good idea for generally excluding drafts from under poorly fitting front doors.
Now, let's have a look at how the thermal imaging camera identifies where heat is leaking out because the insulation is inadequate. This 1970s house is very typical of many houses built in the UK in huge numbers and relatively cheaply at the time. It has no cavity in the upstairs walls and instead just has tile hanging over breeze blocks. As you can see clearly, the radiators are glowing bright red through the walls below the upstairs windows, causing a lot of heat to escape outside and wasting a lot of the householders' money too. There's a simple, cheap and quick fix for radiators under windows. We can create a reflector from aluminium cooking foil wrapped around thick corrugated cardboard to go behind the radiator. Or you can buy foil covered bubble wrap in most DIY stores. Once it's stuck in place on the wall behind the radiator, it will reflect the heat back into the room instead of letting it go out through the wall. Another option for cold walls is to stick insulating wallpaper on them. This wall rock product is listed by the Energy Saving Trust, and as can be seen in this image, a wall which was partway through being covered with wall rock KV600 was already about 1 degree C warmer compared to where the wallpaper hadn't yet been applied. And when it was all finished, the whole room felt completely different. This thick insulated wallpaper provides an affordable solution for cold walls and negates the need for expensive and disruptive internal or external building alterations. It can also be used on cold ceilings, for example, in dormer window recesses. Now here's an idea that will cost you nothing. Curtains. They're like a temporary layer of insulation that you put in place each night to keep the warmth in. So if we always close all our curtains at night, it will prevent the warm air in our home coming into contact with the cold glass of the window panes, and this will significantly reduce the heat lost to the outside. Now in this thermal image, both sets of windows are in the same room. As an experiment, the householder decided to close the curtains on the left to see if it would make any difference. As you can see, the temperature on the outside of the windows on the right was 8.6 degrees C compared to 5.5 degrees C on the left, thus proving that the curtains were significantly reducing the heat loss through the glass. The thermal imaging camera can also identify insulation and heating defects. For example, this picture shows a bedroom ceiling in a rented property shortly after new loft insulation had been installed. The blue area in the thermal image shows that this part of the ceiling was cooler than the yellowy red area to the left, indicating that insulation was missing above the blue area. Now, because warm air always travels towards cooler surfaces, this temperature differential across the ceiling will have set up unwanted air movements around the bedroom with unpleasant downdrafts from the coldest part of the ceiling, explaining why this bedroom was so chilly to sleep in at night. Another example is this single-storey extension with a flat roof. The householders sensed there was a problem as they could feel a draft coming down over them whenever they sat in this room, but they couldn't work out why. The thermal imaging camera was immediately able to identify the problem. The purple and black areas you can see on the ceiling show that the void between the ceiling and the flat roof was missing a lot of insulation. As already mentioned, warm air always travels to a colder area, and in this instance the cold purple part of the ceiling was so large and so cool it was clearly driving vigorous and chilling downdrafts, making the room very uncomfortable to sit in. Just as missing insulation is not visible to the eye once the builders have finished their work, so unfortunately are many defects under the floor, like underfloor heating, such as this installation in this thermal image where a whole section is completely missing, which was making this area of the building so cold it was unusable. Fortunately, the thermal imaging camera can pinpoint exactly where any such construction defects are. However, putting them right is often extremely disruptive, so always make sure you use a reputable experienced builder or installer, as house extensions and underfloor heating installations seem to generate a disproportionately high level of defects, judging by the surveys we've done over the last decade. A really valuable aspect of using the thermal imaging camera in your home is that it can detect moisture ingress. Unfortunately, this does occur from time to time, especially as buildings age, but if found quickly, any problems can be rectified before too much damage is done. In this instance, the householder asked us to check a small mouldy patch on the wallpaper above the wardrobe in their attic room. The thermal imaging camera revealed a very cold area behind the wallpaper extending over a much larger area than the mould was indicating. The shape and the contours of the cold area, the black and purple area in the image, indicate that this was not cold air getting in, but was actually rainwater leaking in from the roof. Urgent attention was clearly necessary. The leak was probably caused by cracked or missing mortar under the edging tiles on the gable end. This was another water ingress problem. This time the thermal images of the outside of a house, showing purple areas where water has got into the fabric of the wall because mortar is missing, and the bricks have then cracked or spalled after being exposed to frosty conditions. This was going to need major repair work, possibly repointing, but the damage to the bricks and mortar was so extensive that tile hanging was probably going to be the best option to weatherproof the wall. If you find any signs of water ingress when thermal imaging your home, you should act promptly to get these issues resolved, and make sure you only ever use an experienced and reputable roofer or builder. The final aspect of surveying our homes, which the thermal imaging camera can help us with, is checking out if our improvements are actually working and reducing our heat losses. This is the really enjoyable and positive part of thermal imaging. But before we look at various examples, it's worth mentioning here that the vast majority of our homes in the developed world use convective heating. In other words, they use hot water circulating around a series of radiators to warm up the air in our homes. This is very inefficient. A much more efficient way to warm up the people in a house is to use radiant heat. In the same way that the sun's rays deliver infrared radiation to our bodies and keep us warm even when the air temperature outside is cold, so do radiant heating panels mounted on the wall or ceiling. But as most of us still have a typical boiler and hot water filled central heating system, and we want to have a comfortable home, we have to stop the warm air leaking out. So we really do have no option but to fix those holes and the gaps and the other cold places in our homes that are driving those drafts, which are making us feel chilly and uncomfortable, and which are also wasting a lot of our money and causing a lot of carbon dioxide to be emitted. And remember, the bigger the contrast in temperature between the warm and the cold parts of our home, the more vigorous and unpleasant these drafts will be unless we do something about it. Heat will always travel from something warmer towards something colder. We can't change that. It's just basic physics. If you want to watch a short video we've made with the thermal imaging camera showing how cooling sets up and drives convection currents, this is now available on YouTube. You can find the link to it on our website. And because heat travels from warm to cold, that's why when we turn off the heating at night, the house doesn't stay the same temperature. It cools down. In the winter, the warmth in our homes is always escaping through the roof, the walls, the windows, the doors, and the floor. So unfortunately, we have to put the central heating back on again in the morning to warm everything up again. And this just gets worse when we have a cold snap and we turn up the heat on the boiler and our radiators. This costs us all a lot of money. And even though what's coming out of a boiler flue looks just like steam, it also contains a lot of carbon dioxide, which is invisible. And if we're all doing this all winter long, we are, every one of us, contributing a lot to those greenhouse gases that are accumulating up there in the upper atmosphere, and that's not good for the planet. So now we know why it's so important to make improvements and cut heat leakage from our homes. So let's now do a quick recap of the ones we've mentioned so far. We've seen leaking windows, which we're able to easily fix with draft excluder tape. We've seen a keyhole that just needed a cover. And we've seen how holes in mortar need to be filled to stop heat loss. And how extractor fans need shutters that close when the fan is no longer in use. We've talked about putting foil behind radiators to reflect the heat back into the room. And we've seen how insulated wallpaper can significantly improve the comfort in a cold room that's got cold walls. And we've seen the benefit of closing curtains across windows and hanging a heavy door curtain across our front door. All of these improvements and more, such as closing internal doors or closing off the conservatory for the winter, will help reduce the heat lost from our homes. We have a downloadable top tips information sheet available on our website, which provides more suggestions. Now, let's go back to the householder's drafty front door we were looking at earlier.
Now we're looking at the outside of the front door again after the draft excluder roll and the heavy curtain across the door have been in place for about 15 to 20 minutes. This has allowed the temperatures to settle, and we can now see that middle panel that was about 6.6 is now around 6. It was 5.9 a moment ago, 5.8. I'll just take an image of that. And then the warmer panels, which are the thinner parts of the wood, instead of 9.3, they are now showing about 7.8, 7.7. So definitely showing a benefit from having a curtain across and the draft excluder roll.
Finally, if you want to improve the efficiency of your central heating system, it's worth trying two very affordable products, Booster Boiler and Endotherm, which together could give around 25% savings on your heating bills. Check these out on our Links to Useful Information webpage. That level of saving, coupled with the savings you could also be making as a result of using the thermal imaging camera to identify and tackle drafty windows, doors and other cold spots in your home, could help save as much as half of your heating bills and will certainly make your home a lot more comfortable to live in. I think that's definitely an aim worth working towards. We hope you have found this video useful, and if you would like to borrow a thermal imaging camera and you live in the New Forest, the Test Valley, South Wiltshire, East Dorset, Southampton, Eastleigh or Winchester, you can make a request on the Schools Energy Project website www.schoolsenergyproject.org.uk by clicking on the Thermal Imaging Survey webpage and completing the request form. If you've enjoyed watching this video, don't forget you can also watch our short video using the thermal imaging camera that shows how cooling will set up and drive convection currents. The link for this is on our website. Thank you for watching.